Imagine receiving a phone call from a ghost. That is essentially what happened at NASA's Jet Propulsion Laboratory in May 2022. Deep in the silence of interstellar space, 14 billion miles from the planet that built it, Voyager 1 began to speak, but it wasn't making sense. For 45 years, this machine had been the most reliable narrator of our cosmic history. But suddenly, the telemetry data, the vital heartbeat that tells engineers how the ship is oriented, detached itself from reality. The data stream claimed the spacecraft was tumbling wildly through the void, spinning out of control. Yet, the signal strength was perfect. If Voyager were actually spinning, its antenna would have pointed away from Earth and the line would have gone dead instantly. The craft was physically stable, but its brain was hallucinating. It was looking into the abyss and sending back gibberish. The engineers were terrified, not because the machine is old, though it is ancient by tech standards, but because Voyager 1 is the only eyes we have in the darkness between the stars. If we lost it, we wouldn't just lose a robot, we would lose our only connection to the outside world. Before we leave the solar system, look down. If that subscribe button is still red, click it right now. We explore the universe's darkest secrets every day, and you don't want the algorithm to hide the next discovery from you. To understand why this glitch was so catastrophic, you have to understand the sheer audacity of the machine itself. Voyager 1 is a survivor of a bygone era, a piece of 1970s hardware built with less computing power than the key fob you use to unlock your car. It was never designed to leave the solar system. When it launched in 1977, the mission profile was incredibly modest: survive for 5 years. Just 5. The goal was to reach Jupiter and Saturn. NASA was racing to take advantage of a celestial phenomenon known as the Grand Tour alignment. It is a specific arrangement of the outer planets that occurs only once every 176 years. This alignment meant a spacecraft could use the immense gravity of Jupiter to slingshot itself toward Saturn, shaving years off the journey. Voyager 1 was the sprinter. While its twin, Voyager 2, took a slower path to see Uranus and Neptune, Voyager 1 was built for speed. It was launched on a trajectory that would take it vertically out of the plane of the solar system, sacrificing a longer tour for a faster exit. The engineers knew that the radiation belts of Jupiter alone were enough to fry the circuits. Every day past the 5-year mark has been a gift. No one in 1977 dreamed that nearly half a century later we would still be tracking its pulse. When Voyager 1 finally arrived at the gas giants, it didn't just send back photos, it dismantled our understanding of the universe. Before Voyager, our view of the outer solar system was grainy and theoretical. We viewed these planets as static points of light. Voyager changed everything. As it screamed past Jupiter, it revealed a world of violence and chaos. It showed us the Great Red Spot, not as a calm eye, but as a hurricane twice the size of Earth that had been raging for centuries. It captured the moon Io, looking like a diseased orange, erupting with active volcanoes, the first time humanity had ever seen active volcanism on another world. Then came Saturn. Voyager 1 dove dangerously close to the moon Titan. Mission planners made a controversial choice here. They sacrificed a potential visit to Pluto to get a closer look at Titan. They suspected it had an atmosphere. They were right. Voyager revealed a thick, nitrogen-rich haze, a precursor to life, obscuring a world of hydrocarbon lakes. By 1980, the primary mission was technically over. The planets were behind it. The camera lens was pointing into the empty dark. According to the budget, the show was finished, but the physics dictated otherwise. Voyager was moving too fast to be stopped. It became a ghost ship, coasting on momentum, headed for the exit door of the solar system. 10 years later, on Valentine's Day 1990, the probe was 4 billion miles away. NASA commands instructed Voyager 1 to do something that had zero scientific value, but infinite philosophical weight. They told it to turn around. It took a series of 60 images to create a mosaic of our neighborhood. In one of those grainy frames, caught in a scattered ray of sunlight reflected off the spacecraft itself, was a speck, a pixel, a pale blue dot. It remains the most humbling image ever captured. That single pixel contained every human being who has ever lived, every war ever fought, every religion, every superpower, and every civilization. It showed us that in the vast, cold emptiness of the cosmos, our planet is nothing more than a lonely piece of dust suspended in a sunbeam. Following that image, the cameras were permanently turned off to save power. Voyager 1 was now flying blind, guided only by its magnetic sensors and plasma detectors, seeking a boundary that no human object had ever crossed. For the next 20 years, Voyager 1 drifted through the heliosphere. This is the vast bubble of magnetic influence and solar wind created by our sun. It protects us from the harsh radiation of the galaxy. But scientists knew this bubble had to end somewhere. There had to be a border. In August 2012, Voyager 1 hit that wall. It crossed the heliopause, the theoretical boundary where the sun's wind crashes against the interstellar medium. At this boundary, the probe encountered a region that the media sensationalized as a wall of fire. And in a way, they weren't wrong. The plasma temperatures in this region skyrocketed to between 54,000 and 90,000 degrees Fahrenheit. Based on those numbers, Voyager should have vaporized instantly. So, how did it survive? The answer lies in the difference between temperature and heat. In space, temperature is a measure of how fast particles are moving. The particles at the edge of the solar system were moving incredibly fast, hence the high temperature, but they were incredibly sparse. The density was so low that there weren't enough particles to transfer that heat to the spacecraft. It was like putting your hand in an oven at 500 degrees versus putting your hand in boiling water at 212 degrees. The water burns you because it's dense, the air doesn't. Voyager sailed through the fire unscathed. Suddenly, the solar wind dropped to zero. Cosmic rays from deep space spiked. The ambient sound of the universe changed. Voyager 1 had officially left home. This brings us back to the panic of 2022. Voyager 1 was now truly alone, drifting in the void between stars when the telemetry data started glitching. The investigation was a nightmare. You have to understand the logistics. A radio signal takes 22 hours to travel from Earth to Voyager. If you send a command to reboot a system, you have to wait nearly 2 full days to know if it worked. It is troubleshooting in slow motion. After months of analyzing the garbage data, engineers found the culprit. The issue wasn't the sensors, it was the spacecraft's memory. The Attitude Articulation and Control System, AACS, had started routing its data through an onboard computer that had been broken for years. It was a symptom of the probe's extreme age. It was like a senile brain trying to access a memory that no longer existed, corrupting the information before sending it home. The engineers managed to reroute the command, bypassing the dead computer. The signal cleared up. The spacecraft was stable, but the incident served as a grim warning. Voyager 1 is dying. It is powered by a radioactive battery, a lump of plutonium-238 that generates heat as it decays. That heat is converted into electricity, but the laws of physics are strict. The plutonium is decaying. Every year, the spacecraft produces 4 watts less power. To keep it alive, NASA has been performing a slow, methodical amputation. One by one, they are turning off the heaters that keep the instruments warm. They are sacrificing parts of the ship to keep the heart beating. The heaters for the cosmic ray subsystem were turned off years ago, yet miraculously, the instrument is still working in the freezing cold. But the power curve is undeniable. We are approaching the end of the timeline. Sometime in the late 2020s or early 2030s, the final instrument will go dark. The last bit of plutonium will decay below the threshold needed to power the transmitter. Voyager 1 will send its final ping back to the Deep Space Network, and then absolute silence. But silence does not mean the end. Bolted to the side of the chassis is a gold-plated copper phonograph record, the Golden Record. It is a time capsule with a shelf life of 1 billion years. It contains greetings in 55 languages, the sounds of wind, thunder, and whales, the brainwaves of a woman in love, and music ranging from Bach and Beethoven to Chuck Berry and Blind Willie Johnson. It also contains a map, using pulsars as landmarks to triangulate the location of Earth. Long after the transmitter dies, Voyager 1 will keep moving. It is currently traveling at 38,000 miles per hour. In about 40,000 years, it will pass within 1.6 light years of the star Gliese 445. But it won't stop there. It will drift through the Milky Way for eons. Long after our sun has expanded and consumed the Earth, long after humanity has either evolved into something else or gone extinct, Voyager 1 will still be out there. It will remain as a silent monument to a species that once looked up from the mud and dared to reach for the stars. It is the longest-lasting thing we have ever made. The story of Voyager 1 is not just about data or planetary science. It is a story about the human need to be remembered. We built a machine to shout, "I was here," into the infinite void, hoping that perhaps, just perhaps, Something out there might one day hear it. We are living through the final chapter of this mission. Every bit of data we receive now is a bonus, a whisper from the edge of existence that we are lucky to hear. If you enjoyed this journey into the unknown and want to support the channel, the best thing you can do is hit that subscribe button. We are building a community of explorers here, and I want you to be a part of the next discovery. Thanks for watching.